So hi everyone. Now today we'll be starting with a new question called n queens. So this is a classic question of backtracking. So the question states that we have been given a chessboard of size n cross n, and we have to place n queens such that no two queens attack each other. Now we have been given an integer, and we have to written all the distinct solutions of the n queens problem, and the answer may be in any order. Now the question is in the format of string, and so we have to written in the format of vector of string, and each solution contains q, and q represent as queen and dot represent as the area or the space is vacant. So now we'll be diving deeper into the problem. So in an n queens problem, we take n as 4. Now how many ways are there to put 4 queens in 4 cross 4 chessboard? Now, in how many ways we can put 4 queens in a 4 cross 4 chessboard? So, there are 4 possible combinations in a row. That is, we can place any queens in 4 ways in a row and 4 ways in a column. So, total there are 4 into 4, that is 16 vacant spaces, and we can put 4 queens, or we can put a queen in any of the one vacant space, and total there are 4 queens. So we have 16 options, and the number of queens we have to put is 4. So total 16 c4 ways we can put 4 queens in 4 cross 4 chessboard. Now what if there are n queens? So in n queens we can have n cross n into n c n. That is, we can place n queens in n cross n chessboard in n square into n square cn format, n square cn ways. Now coming to state space tree. So basically a queen, it attacks in 8 directions, like in a row, in a column, and diagonally. So when we ignore in the form of diagonal, like we only consider 4 directions, then a state space tree is created. Like we put queen in the form of this, where there are no queen in any same row or column. Then the maximum number of nodes which we can have is this. This can be the maximum possible nodes, but as we know that queens also attack diagonally, so there are total 8 possible directions. Now coming to the approach of the problem, a queen can attack in 8 possible directions, like upwards, downwards, left, right, as well as diagonally. So the no two queens should be placed in the same row or same column or diagonally. Like if we place a queen in the first row, then we cannot place another queen in the second column of a same row. Like even if the column is different but the row is same, so these two will attack each other. And even if the row is different but the column is same, then also they will attack each other. Moreover, if the queens are placed diagonally, then also they will attack each other. So what we have to do, we have to find in how many ways we can put n queens so that they do not attack each other, and we have to consider all the 3 restrictions of it. Like it should not be put in same row, same column, and diagonally. Now we can have a number of combinations, like we can place here, 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 but upon seeing closely we see that they attack each other, and these two attack each other. So the next example we can see, if we place a queen like this and the mirror image of it, that is like this, we can see that there are two solutions of the problem. There are two solutions of the problem, as no two queens attack each other diagonally as well as horizontally and vertically. All these you can see they do not attack each other. So these queens as well as these queens placed in a chessboard are two valid combinations for value n is equals to 4. And now the big question arises as how it came. Like, we can see there are a lot of possibilities. We can see that there are a lot of possibilities, like for n is equals to 4, there are 16 C4 possibilities. Then if we go n to higher order, then it will be a lot of possibilities, and we cannot calculate it by greedy or other approaches. So the thing we have to do is we have to find we have to find all possible combinations, and then we have to calculate which solution will fit our given condition. So which solution will fit our given condition? Now let us dive deep into it and see what is the recursion tree, or what can be the valid possible combination, and what is the intuition of the approach. Now we'll be solving the recursion tree of the problem visually. So we have to keep in mind these three conditions. We have to keep in mind the three conditions, that no two queens should be in the same row or in the same column or diagonal to each other. We have to keep in mind these three conditions, and then let us proceed. Okay, so now we have four options to place a queen. So we'll be starting with a column, and that is, we'll first start with column 1, then we'll go to 2, 3 and 4, and we'll see that whether we could place the queen accordingly, or we could place the 4 queens in such a manner that these three conditions are valid. Now initially the board is empty, that is, no queens are placed here. So let us first place the queen q1 here. So let us first place the queen q1 here, and we name it as q1. And in the second column, as I have said, that we would put according to the column wise, and we'll see that no two queens attack each other. Then first we have placed in the column row 1 of column 1, then we'll place in the row 2, and it is also q1, and in the row 3 q1, and the row 4 q1. So these are the valid combinations of placing the first queen in an 4x4 chessboard. Now to place the second queen here, we have two options, as we cannot place it here and we cannot place it here, as it will attack horizontally and it will attack diagonally. So the two options that is remaining is the third as well as fourth. So we'll first put it here and then we'll put it here, which are the two valid possible combinations. And now we'll see further as to what is the possible solution. And now in order to place the third queen, we see that we cannot place it here, as it will attack diagonally. We cannot place it here, as it will attack horizontally, and we cannot place it here. The only possibility that is remaining is here, but q1 will attack it, so this cannot be. So q3 cannot be placed here as it will violate the terms. So remove we'll backtrack and we'll remove q2 from here and we'll backtrack. Now going to the fourth option, that is going to the third column, we see that we cannot place the queen here as it will attack. We cannot place the queen here as it will attack. We cannot place the queen here, it will attack. This will attack. And so the only option that is remaining is here. So now we'll see the further possible combinations of it. On placing the third queen, that is q3, we find that these three queens are kept such that these all do not attack each other. Now the only option that is left is placing the fourth queen. Now let us see what can be done. So the queen number 4 cannot be placed here as this and this will attack. It cannot be placed here as q3 will attack. Now it cannot be placed here as q2 will attack, and it cannot be placed here as q3 will attack. So this column, that is column number 4, we cannot place the fourth queen. So in the column number 4 we cannot place the fourth queen, and thus we have to backtrack the option and by removing the q3 and then q2, as these are not valid. We have to remove all that. We'll pop. So we will backtrack and we will remove these combinations, and thus the only thing which is remaining is q1. Now this possibility is not valid, so we'll backtrack and we'll remove q1 also from here, and then we'll move to the second option. Now in the second option we have to place the second queen in such a way that all the 4 queens do not attack each other. So now we have these options which cannot be taken. So the only option that is remaining is here. So we put the second queen in the 4th row of second column. Now moving to the column 3, we put the queen number 3 and we have to find out which is the valid space where we could put. So these cannot be taken as q2 directly attacks it horizontally. This cannot be taken as it attacks it diagonally. q1 attacks it horizontally, so it cannot be taken. So the only option that is remaining is for q3 is here, which is safe. So q1 is here, q2 is here, and q3 is placed here. So coming to the fourth possibility, we see that these spaces cannot be taken as it is horizontal. This cannot be taken as it is horizontal. This cannot be taken as it is horizontal. It attacks it diagonally also. So the only space that is remaining is here, and we do not have to explore it as the only thing that is remaining is here. So we'll return it from here, and then we'll explore only this possibility. That is, we'll place q1 here, q2 here, q3 here, and q4 here. So we got one valid answer. We have got one valid answer. So we place it inside the array of string, as this is the answer. Now we cannot move here. So we'll backtrack, we'll return, and this, now coming to this, these options can, there is only one possible combination, so we'll also backtrack from here, and this is not a valid combination, so we'll backtrack. And then this is not also, this is also not a valid combination, as we have only one option, so this is return, will return from it. And then it is the mirror image of the first part, and we'll get the answer, that is, we'll get an answer which is the mirror image of this one, so it's just a replica of it. So I will not go deeper into it. As so now let us go to the code and I'll explain it to you what further it is required. Coming to the backtracking approach, we have been given an integer which is the size of the chessboard, and here let us take as 4. Then we have to return the vector of string, means array of strings. Now what does it mean? Like here we have initialized s, and if n is 4, we take 4 dots, as we initialize n, that is we initialize s with the size of n, and we place dot here, and dot means vacant space, like this is a dot, this is a dot, this is a dot, this is a dot, this and all these are dot. And if we place a queen here, then it becomes q. So the queen is represented as q for vacant space, and q is for queen, and q is for queen. Now we take v, like we run a for loop from 0 to n and till n minus 1, 0 to n minus 1, and we push, like we initialize the 1D vector or 1D array of string data type, and then we push the values of s, that is dot dot, the 4 dots here, the 4 dots are similarly, the size is 4, and the dots and the size of string is also 4, so the resultant array that becomes is this. And the answer array, it consists of the combination, or it consists of the valid possible combination of the answer, which is, let us take an example of n is equals to 4. So there are 2 valid combinations of vector of string or the array of string, so here 2 vectors are stored in a vector of vector format or in the array of array format. So this is all the statement talks about. We initialize a vector of vector string, and then we initialize a 1D vector. It is a 2D vector which consists of string data type, and it also consists of string data type. So we initialize the vector initially as v here, and then we pass it to the recursive function. Now the command comes to the recursive function, which is of void return type, as we have passed the answer by reference. So we'll move forward. Now the base case, as we see that we move column by column, that is we move column wise, so the size of row as well as column is n. So we move column wise, and therefore if the column index, or if the column reaches to n, which is here 4, or the index reaches to n minus 1, then we will store the value. As it means that we have successfully placed all the 4 queens such that they all are safe and they do not attack each other. So this, let us take this as V, and this answer or this column value, basically this is an increment operator. Like here we have passed through 0 index and the command comes to 0 index, and then we'll move forward as I have explained it in the recursive tree. We'll first move to the column 1 and we'll place the first queen, and then we'll move to the column 2 and then place it accordingly. So here this is the first answer, and then we'll store it in the vector of string, which is the base case of the problem. Now here we can see that we choose a column and then we traverse row wise recursively just to get the answer. We traverse row wise recursively just to check whether we can place the queen here or not. Or just from, we take an example of 1, 1, can we place the queen here? Or 1, 2, 1, can we place the queen here? 3, 1, can we place the queen here? 4, 1, can we place the queen here? So yeah, these are all the valid, or these are all the combinations and recursive codes that will go through. So firstly, I will start from the 0th index or the first row, and initially the column is also initialized to 0, and then we'll check whether this is safe or whether this is safe. So initially the chessboard is empty, so we can place the queen here. So after that, if we can place it here, so the board which is in this format, we replace the dot, that is, if we can place it here, then we replace the dot as Q. Okay, and we'll then pass it to the recursive code, and with the command, that is, we place it here and then we'll move forward and we'll pass the command to the next column, that is column number 2, or the index of column is 1. And then if we cannot, the recursive code is passed to the next form and to the next form, and if we cannot place it here, then we'll backtrack by popping out the thing which we have placed, that is the queen which we have placed. So this is here, we pop out, or we will just replace the value of Q as dot or the blank space. So this which we have initially placed, so the queen which we have placed, replacing the dot, then we will again represent it by dot according to this line. Now what does isSafe function do? Now let me explain it deeply. Now the command will go from isSafe function, will pass row, column as well as the board. These two are not necessary, but if you can pass. Now the command reaches to the bool isSafe, in which we have row, column and the vector of string, that is the array which is given to us. Now in this safe format, suppose a Q is placed here, a queen is placed here, and we want to place the second queen. So initially we'll just take a empty array, or empty variable which we name as n row, and we place the value of row, as we will check the value in this format. Suppose we have to place a queen here, then we have to check horizontally and diagonally in 3 directions as whether we could place the queen accordingly. So thus, to maintain the original index, we just have to take a variable name as n row n col, just to maintain the originality or the original value of rows and columns, as we will traverse just to find out, as we will traverse up diagonally and vertically, horizontally, as we will traverse diagonally and horizontally, just to check whether we can place it or not. For example, if the command comes from into column 2 for placing the second queen and the row value is 2, like here, so we'll check whether the queen attacks here horizontally. So yeah, it attacks, so we'll just return false. Let us take another example. If column value is 2 and the row value becomes 3, then it will check whether we can place it horizontally. So yeah, we can place it. Whether we could place it diagonally, so no, we cannot place it diagonally because the queen is here. So can we place it here? Now we will check it horizontally. We'll check it diagonally. So yeah, this is not contradicting. So this is not contradicting. So we can place it here, and then we return true from the isSafe function. And if any two conditions have arrived like which is contradicting, then we'll return false. The queen can attack in 3 ways, and the equation is, or the index is I-1 and J-1, where I is the row and J is the column, and this index is column -1, or sorry, this index is I comma J-1, or row comma column -1, and let us write it row -1 and column -1, and this is row +1 and column -1. So these 3 indexes, we have to check it thoroughly just to get the answer whether it is safe or not, and we go till these values does not reaches to the end point, like I-1. If this, as it is decrementing, so I-1 will be checked through 0. If the value is greater than 0, then we'll continue, and if the value becomes negative, then we'll return back, which is this while condition. So this handles the left diagonal or the upper diagonal case. And then if the condition is like the end point, if it reaches the end point, that is 0, then we just return from the while loop, and it will just check it. Then we'll just check to the next format, like if the value is here, and we check there is, if there is any queen. So no, there is no queen, so we'll just check another, like we will check horizontally. But first we will, okay, first let me erase it. It has become such a mess. So yeah, then we'll check it horizontally, but first we have to change the value of row to the initial value, that is n row. Why? Because if we are moving by decrementing the row and column, like row minus minus and column minus minus, so that if the initial value is 2, 2, then we have to check it, that is 2, 2 comes here, then we have to check it from, like we have checked in the upper diagonal side. So now we have to check it from the 2, 2. So we'll just reinitialize the value, as the value has now become this, as the initial value has the row value became 1 and the column has also become 1. Sorry, the row value became 0, column value became 0, and the row value became 1. So this exited this while loop, so we have to reinitialize to the original value. Now on placing the queen, like if the queen is here, we have checked the upper diagonal side, like whether it is contradicting the condition. No, it is not contradicting. So we'll move, like the pointer came across in this format, then we'll reinitialize it to the original value or the original index, and then we'll again check whether, like, when while column is positive means we'll decrement or we'll move towards the left. So we'll have the condition that with the it is not, so it does not go out of bound. So we'll check that is that is horizontally leftwards, whether is there any queen. We'll check. So yeah, this is contradicting, so we'll remove it, or we cannot place it here. And if the example is like the second queen is here, then we will check it. Okay, so this condition checks upper diagonally. So this condition checks upper diagonally, this condition checks horizontally, and this condition checks lower diagonally, like this part. These two are checked, and now we'll move to this part, like this lower diagonal part. In this lower diagonal part, we are decrementing the row as well as, sorry, we are incrementing the row as well as we are decrementing the column. So accordingly, we make a check that row do not go out of bound and the column do not go beyond 0. So yeah, these two conditions are valid, and we check whether any queen is here, like it is placed here. So we'll check whether the row value or column value is greater than 0 or this. So this condition is false, so this condition is satisfied, and we'll move to next, as row is 0 and column is 0. So we'll move to the next. Is there any queen horizontally? So no, there is no queen horizontally. So will the pointer or the command move to this part. We have reinitialized it, I have explained it earlier, and then we have applied the condition here, and then we check lower diagonally, keeping the condition in mind, that whether there is any queen in the lower diagonal portion. So yeah, coming to this condition, it is, so we'll return false. So what happens if we place a queen here? So first condition is satisfied, that is it do not violated the upper diagonal condition. It does not violate the horizontal position, and it also do not violate the lower diagonal position. So it becomes out of, so it satisfies all three conditions, and then we return the value as true. So now I'll code it up and we'll see the further question of it. So I try and let us see if it, yeah. So our approach is backtracking approach. There can be a optimal approach, but we are in our backtracking series, so we'll see the approach in the further videos. So yeah, thank you all.